Welcome to another episode of Code for Thought. This year's conference for research software engineering, SeptembRSE, is now drawing to a close. But before it ends, here's another extra conference episode. And this time I'll be talking to Apeksha, James and Natalie from Amazon Web Services. AWS is the biggest cloud provider. But as with all providers, getting to grips with cloud services can be very daunting. That's because cloud providers have a large and ever-growing number of components available. In our discussion, we talk about approaches how to tackle that complexity. And here now my conversation with Apeksha, James and Natalie. Welcome Apeksha, James and Natalie, and welcome to the show. Let's start with some introductions. Can I ask you first, Apeksha?
Hi, my name is Apeksha Jain. I'm a AWS Solutions Architect. I've been working with Amazon for nearly about 4 years now. I started myself as a software engineer, working on AWS's billing side, and then decided let me dive into the solutions architect role. And I've been doing that for about 3 years, starting with financial services, and now I'm completely focused on education and research.
James.
Hello, everyone. My name is James Grant. I'm also a solutions architect in the education team at AWS. I have a research specialism within the team, and my background was that I was a central research software engineer at the University of Bath until the beginning of the year, when I worked with researchers across the university and the regional high-performance computing system Isambard.
Natalia.
I'm a solutions architect intern in the same team as James and Apeksha. It's just for the summer. I'm going back to school in a couple of weeks, and school for me is King's College London, and there I'm studying electronic engineering.
Well, I hope we talk a little bit about the internship a little bit later on, and that sounds quite exciting. But let's start. It's the SeptembRSE annual conference, and Amazon, in fact, is one of the sponsors. So my first question would be, how did you get into that, and what do you try to achieve with the sponsorship?
AWS have sponsored a number of the research software engineering conferences before I started. But I think with my background, I think it's really important to focus on research and to work with the RSE community. So I was keen to see that we would support the conference again this year. We're working on a number of events. Obviously, I'm pleased to join you for this podcast. We're running a workshop as a peer-reviewed contribution where we're going to offer attendees the opportunity to explore working with big data, using some analysis and visualization. And we're giving a talk. So one of our other interns, Martini, is working on a project with the University of Bristol. So we're going to talk about that towards the end of the conference. We really just want to support this community, not just in one-off sponsorships, but in understanding how we can work with the society to support research software engineering, the work of the society and the community. One of our leadership principles at AWS and Amazon as a whole is customer obsession. We want to work with you, our customers, to understand your challenges and help you to achieve your goals. Really, starting that dialogue is really important so that we can support the community.
So for me, this is a first time coming from financial services into education. This is my first time where I'm actually getting to see what do RSCs, how do they support research? Because I talk to researchers and I talk to IT, but I don't get to talk to RSC community myself. For me, a really good opportunity to see how RSCs are sitting between the two, the researchers and the central IT, and what can we do, as James has rightly said, to help out RSCs into making better utilization of cloud.
What do you think is the relevance of the research software engineering community? Why bother, if I may put it bluntly?
Well, it's my community. We're a great place, right?
Indeed.
I think one of the key things is that research software engineers are builders, and AWS is a platform where builders can imagine and invent, develop new features for the future for their research to help drive on the research. And as opportunities arise to work with the community, and hopefully the workshop and the talk we're giving, this podcast will be a seed to starting those conversations. I'm really excited to see what the community can do. And in questions like that, I'm always reminded of, and I mentioned this in the lightning talk that we gave as part of the work, the conference. When I started in my central role, the director of IT referred to the RSE position as the Colossus of Rhodes, standing
Really?
standing structurally between central IT and researchers, mediating better relationships. But whether it's technically, the role itself is combining research and software engineering and bringing those expertise together. That analogy just drives home. RSEs teach. They're going to be teaching software, they teach methods, and they're going to be teaching cloud technology. And then you look at what the community has achieved over the last nearly 10 years now, driving change not just for research software engineers, but for other groups that have struggled to make sure they get the appropriate recognition and opportunities. So anything we can do to support that community, I think, is hugely important.
Amazon Web Services is one of the biggest cloud provider. Well, it is the biggest cloud provider at the moment for quite some time. A lot of people will be familiar with that, and I think that a number of universities have already signed up for that. So what do you think is the future of cloud services in research?
Amazon really helping, or AWS really helping the research communities, really reducing down that time to science. Because whenever we talk about on premises, there's quite a bit of overhead of time that is required before you can procure your servers, you can stack them, rack them, make them configurable enough for users to use. And then researchers have to queue up to use these on premises services for quite some time. Whereas if they want to use cloud services, within few clicks of a button, they can have their own servers at their disposal. What really AWS helps is reducing down that time to science from where they need to when they actually get those resources have been drastically reduced down. So that's one of it. The other thing is, along with these, we also provide you with not just the basic compute and storage and databases. There are
Hmm.
also advanced technologies that are becoming more democratic for everyone to use. So, for example, machine learning. I myself did not study machine learning at university, or did machine learning specific work prior to being a solutions architect. But with the technology so easily available and at different levels of abstraction, I can now start using machine learning to my advancement. I can start using data analytics for my use
Hmm.
cases. I can start using IoT for what I need. So, all of these advanced technologies are becoming more easily available for people to use. So, this also increases the innovation that researchers or RSC community might want to do and make use of these advanced technologies. And along with all of this comes the question of costs, because nothing
Yes.
comes for free. And that's where cloud is another place which it helps out, because you're only going to be paying for what you're using. So you can then use your resources or financial resources that you save up to invest somewhere else.
So where do you still see on-premise services coming in then? Do you think it's going to be phased out completely in the long run, or do you still see there's a place for that?
I think it's going to be some time before customers can move completely to the cloud, because we are working with our customers,
Hmm.
but there is some upskilling required. There's still quite a lot of people I find where I have to explain why cloud and how they can get onto it and how they can use it. So slowly but surely we are moving towards that direction.
Which is a nice segue into my next round of questions. Actually, the focus, which is education at Amazon. I think all three of you are somewhat involved in that part of Amazon Web Services, if I remember correctly. And Natalia, you, for instance, are an intern in that area. How does your education work come into AWS? I mean, what is it that you focus on?
The question that you've asked makes me laugh. The reason is There's just so much, the breadth of work that we do. It's really difficult to define. Like I did this talk for someone, and instead of saying day in the life of solutions architect, I said a week or a month, because it's difficult to say all the tasks that we do can be done in a day. Part of it is educating the customers, letting them know what is there. The second half is, because there's such plethora of services that they can use or technology that they can use, we also need to be around to guide them to make the right decision. So it's always working backwards from what they want to what they're building. So really understanding what their requirement is and building that out, or helping them build that out using the right kind of services that they use. The other part of it is, once you've built it, how do you improve it? Because innovation is constant with AWS. Every year we are releasing thousands of features and new services. How do you make sure you're using the latest ones to your advantage? It is constantly improving, reducing down the cost, or increasing the reliability of your application, or increasing the performance of your application. That's the other part that we would be working with customers quite a lot. And then there's the other part where, since we work with so many different customers, it's always good for them to know what others are doing, so that knowledge can be passed along. So creating that community is also a part of the job that we do.
James, I think you wanted to say something as well.
I think I was going to come back to sort of more core programs that we have in terms of the providing education opportunities. We have AWS Educate, which is a platform where our customers or anybody who's interested in learning about AWS can, certainly within education, you can sign up for an account, and there's a wide range of materials that you can work through. And then from an institutional point of view, we have AWS Academy, where institutions can sign up, and the content is delivered by academics. So your existing educators with their teaching expertise can incorporate materials within their courses or run specific modules so that their students can learn about cloud.
Natalia, you're an intern, and I find it quite fascinating. And you say you're going back to school. So how did you get into the whole thing and being an intern? And what does it actually mean? What do you do there?
Around January this year, I just finished my second year of uni. I'm going to my third and final year. Somewhere between second and third year is when most students do their internships. I applied for quite a few internships, and then I saw this internship being advertised on the AWS website. Didn't know much about it. I tried to look it up, and a solutions architect, as a picture has said, there's a lot to it. So I didn't really actually understand myself exactly what it was all about, but I accidentally stumbled upon a webinar where someone else in this team has been doing a presentation on the internships that are available and what it's like. When I got invited for the interview, I had them, and I accidentally already knew the interviewer because of this webinar. So that's kind of how I knew about it. And then after the interview process, I got the internship offer, and then a few months later, I got to start the internship. So that's how I got into it. As an intern, what do I do? I've been given basically a few key projects that I need to handle, and it's like, that's what I do for the whole of the internship. There's these like 3 deadlines. One of them is an exam, but then apart from that, there's other interns as well, so I interact with them, or there's events, or so I just help other people in the team in different ways.
It sounds like there's a lot going on in AWS Educate. So could you highlight some projects that you've been working on that you might want to talk about?
A customer to AWS, they're doing research into how climate will affect the growth of different plants. That's to a vague extent what they're researching. And they wanted to be able to collect that data into AWS. Someone in the team has already started on doing that, and then my project has been an extension of that to find how we could use sensors to maybe get some other metrics and then send that to AWS. So in my case, it was the height of the grass, how we can find that, and that was an interesting problem.
Picture. Cloud architecture can actually be quite complex, and as you say, you can get up and running quite quickly with some basic stuff, but in actual fact, there's quite a lot to learn. What advice would you give people to actually get to grips with that and where to start?
The thing is, the basics are still the same. Like you've rightly said, it's easy to get started, but the basics still remain the same. It's just a new way of doing things. So, how do we get around to this new way of doing things, or how do we learn this new part? And for me, the way I learn, I've seen that people learn through different mechanisms, but the way which I've seen work the best is trying out. You can read all about it, you can do all the exams in the world, but unless and until you start building and trying out, you don't really get it. So when I started myself at AWS, I did not know anything about the cloud or about AWS. And the way I learned myself is I used to look into a smaller problem statement and try to see how can I build that. So I would try with a couple of different technologies and then see their performances, how does it work, what are the downfalls, and then slowly start to build the problem statement bigger and bigger. And that's how I learned. There's always tons of free resources which are available on AWS's site. So there's a lot of free digital training which is available. 100% recommend going through that. We've got quite a few partners as well who go through different courses. For example, if someone focuses on security, they can go through the security training if that's something that interests them. Or if someone's, for example, a networking engineer, they might want to focus on networking. So there are different tracks that are available where you can use your existing knowledge and then convert it or adapt it to this new way of cloud and learn about it.
I completely agree. I think within the RSE community, we do a lot of teaching in terms of programming and the methods. And I think a lot of those practical aspects are just as relevant when it comes to learning about cloud. Gaining confidence in the basics, first of all. So I'm preparing a workshop at the moment and thinking about these problems quite hard and having a lot of support from the team. Being familiar with the fundamentals, exploring the console, knowing how to move around in it, and then gradually building up and understanding how to interact programmatically with the API to create resources. And then again, as Apeksha said, there's all these building blocks. Putting those building blocks together is something that you develop. So incrementally adding new functionality, learning about new services and features of those services.
There are quite a few building blocks, though, aren't there? And they seem to be increasing. You started off with a very simple set of Lego blocks, and it seems to be increasing in shape, form, and complexity. So how can people keep track of that? And, speaking from personal experience, sometimes quite difficult to actually make sense of it all. So it seems, oh, this sounds interesting, but then the question is, do I really need that? And how do I assess if I need that? I guess it's also part of your workshop, James. So sorry about if I preempt that.
No, you're completely right, Peter. Like when I talk to customers and there's like about 200 services, the first thing I tell them is you need not know all of them. My job is just to focus on AWS. And even then, I can't be an expert in all of these different services. So I can't expect any of my customers to know all of them, right? I always say start from what your problem statement is and work backwards. And that will give you a good guidance on what is required. So, for example, if you're building a simple 3-tier application, you need not, for example, know about the IoT services which are out there. You need not know about, for example, say robotics service or the satellite service which is out there. That's not required for your 3-tier
Yeah.
app. So that's where you can start. And once you've got this confidence in the basics that you can do what is required for you to build, that's when you can start understanding these other plethora of services which are around. So you can then start playing around with, okay, now I know how to do compute, networking, and databases and storage. Let me now go ahead and explore how can I make sure that I'm monitoring my application well, or let me go and see that how can I automate once one of my services is down, how can I automate that remediation method. And slowly you'd start building up those skill sets. If we start looking at the different streams and different verticals that we have and start exploring all of them, it can get very overwhelming. So I always say start small, start with what is needed, and then start expanding on it.
Yeah, I think that's a very valuable tip because as engineers, we tend to get very excited with new technologies and it's very easy to get distracted with all of the stuff that's out there. Yeah, the problem statement, sort of the kind of use cases, right? What's the use case? You start with that, and then sort of what is the essential services that I need for that? And then once I've got that in place, then I can start thinking about the next step. What kind of monitoring and other services to make it more robust and maintainable and scalable can I add? Is that what you're saying? Sort of the kind of stepwise approach?
Exactly. The other thing I would say is like one thing that people try to do is people try to build applications that never fail. And one of our famous quotes from our CTO is everything fails all the time. So it's not about trying to build something that never breaks down, but it's rather to build systems which either remediate themselves or give you notice of when they're breaking down. So when you start that those simple mindset change, when you start having those,
Mm.
I think even they make you a better builder, or they make you focus on the right things rather than try to build something that never breaks or try to learn everything altogether.
On that, I think there's an analogy with what we do in software engineering and research software engineering. We have the idea of get it working first, make sure it's right, and then begin to look at improving performance or refactoring the code to make it more accessible. When we're building proof of concept projects with customers, we have certainly internally we have the idea of a minimum lovable product. Getting something that demonstrates the key functionality is the first step. Then we can make sure that all the other features that are required are there.
So RSE is quite interesting because it sits in this weird intersection between the IT services and research, right? So the IT services usually are the ones that are responsible for the infrastructure. They're usually the ones that might actually look at on-premise services. And RSEs write programs. But what we're talking about here is also almost like an infrastructure engineer or almost like solution architects that we need on the university side. And that also is quite a mind shift. So, how do you think we get to the universities to recognize it a bit more?
So, something that we are working on with the universities is building the cloud center of excellence, or different people call it different things. Some call them cloud ninjas. Everyone comes up with fascinating names. The simplest of the names that is there is Cloud Center of Excellence. So, it's a community of small set of community of people who come from different sections. So, they will come from security, they'll come from networking, some will come from software
Mm.
engineering. So, we've got a viewpoint from all of these different ones, and we build this cloud center of excellence along with the customers. So along with the university, we would build these, and they can then help out within the university. You're not relying just on AWS or to search up information. You've got this entity or this community within your university to go and request for help, and that's where you get all of these different perspectives. So if you're building an application or you're thinking of building an application, already
Mm.
you've got this community which knows how to look at it from a security point of view. They know how to look at it from the networking point of view. They know how to look at it from the cost point of view as well. And then they can give you advice accordingly. And the best thing about building this cloud center of excellence is it is by the people who are at the university. So they know what works well in their university and what does
Mm.
not, because all the universities have their own governance and their own regulations and their own ways of working. So this cloud center of excellence can really embed themselves within the organization and enable other people to build their application. And slowly this starts building up and up. Initially, you've got someone who's done a couple of projects, so has some
Mm.
knowledge of it, and then they start building templates, which then can be used by other people. So there's also increased reusability because of this cloud center of excellence.
I think once you begin to get experience of working with AWS services, Lancaster University, to take an example, they developed an Alexa skill to enable their students to access information about the university. So, when was the sports centre opening? When was their next lecture? To try and answer those sort of questions, and then having gained that experience, the central IT team then supported a research project where the aim was to develop a chatbot to support medical patients. Once you get that core experience within the institution, then it can begin to be applied in other areas. I think that's the value of developing this core competency within organizations. And I think in other aspects, the research software engineering community is going to be a key driver there.
There are two difficult questions, or at least they're difficult for me. They may be very simple for you to answer. One of which is education in general. So we've now just come out, or are about to come out, from the longest lockdown and a rather strange period of online training and online training services. We're moving more and more services to the cloud, and even before the pandemic, more and more education services have already been provided online. Do you think that, from your perspective, that education will retain part of its online character in future and perhaps even enhance it? Will there be even a classroom, and will we be needing to develop education software very quickly now? What do you think?
I'm sure Natalia will have some comments on this as a learner who's been through it, but if I can jump in first, I just want to say I think it's amazing what the education community has done, and that's not just in higher education, but across the spectrum. We have had to change and adapt to so many new technologies over the last 18 months, and it's a real credit to teachers, lecturers, our departments of learning and teaching and central IT, that we've been able to maintain teaching in any capacity. And I was there back in March last year, having to think about how to deliver remote teaching. Greg Wilson, who's famous for software carpentry, certainly within our community, gave a webinar where he talked about how over the next 18 months, we'd be creating more new ways of teaching remotely than had been done in the last 30 years. One of our senior leaders on the education side recently was part of a blog post where he noted that education hasn't really changed in 1,000 years in higher education in the UK. Certainly there are things that have worked, and other areas where we probably have to still work to do.
Natalia, you've been through all of this now. You've been at the sharp end of the lockdown.
I think I just want to say as well, so you were saying how, maybe the classroom will go altogether and you won't need a physical classroom. But I can say from my experience that there's two sides to this. So before the pandemic, whenever there were large lectures, they also had a physical recording. They had a recording of the lecture and they put it online for students who missed the lectures.
Right.
And essentially most students, maybe at first would come into the lectures, but most students would eventually default to the backup, I'll just watch it on the recording. That's basically what happened. So this was already a preference for students to be watching their lectures online.
Right.
But not the tutorials, which is like a smaller group of students. When the pandemic came and lectures were put online, this was already a preference. So it wasn't that big a deal, but with the innovation that came with that to improve the experience, it's no longer just a backup, it's now the default. And I think that will continue on and students will like that. I just got my timetable a couple of days ago and it's quite a lot of it is still online, like the big lectures, and that's perfectly fine. That's great with me. And then the smaller tutorials are in person. So I think this hybrid solution is what's going to stick around.
So that kind of hybrid solution is a way forward. Yeah, that I agree. The final question is probably a little bit difficult to answer for AWS because it's about the fact that, yes, there is AWS, there are also other cloud service providers. And as universities, that might be difficult to navigate which cloud service to go with and what they offer and what the costing structure is and the benefits and the downsides. How do you think we should navigate this?
I think all of my answers seem to be quite similar here, like working backwards from your problem. So I would say rather than going through and trying to analyze every possible option that you have out there, start with what your problem is and start from there looking into what the best options are. If you just go trying to blanket assess which is the best cloud, obviously I'm going to say AWS, but if you just go with those blanket assessment, it might become difficult for you. Rather than that, if you start looking at this is my problem statement, how do I solve this? If you want to look at the scale and breadth of services of all the different options that are available, then definitely AWS has the maximum number of different kind of technologies which are out there
Mhm.
available. You need to start assessing on what are your needs and what fits for that needs, and that would be my recommendation to go with, is define your problem statement and work backwards from that. And then there's always support available around it for you, whether it is ongoing application support that you need, or if there
Mm.
is guidance that you need. AWS are always more than happy to answer those questions for you.
I'm just thinking, I mean, as Apeksha said, it's really identifying applications or services on a case by case basis. What is it you want to achieve when you're moving to cloud, and having a clear idea of what it is you want to achieve and where you want to get to, and that will help make sure you get there successfully. Natalia mentioned her project as part of the internship. Martini's project that we're talking about next week as part of our talk. I think developing those proof of concept ideas, seeing what's possible. Apeksha mentioned some of the machine learning services as an example. So Martini's project will be incorporating the voice activation or a chatbot,
Mhm.
and incorporating that with a research simulation framework on the back end. And it's only really when you start playing with those that you can begin to see what's possible, and really think about how we can reimagine the future.
Okay, well, thank you very much. We've now reached the end of the podcast. That was a very good and exciting discussion today. I think we learned a lot. And, identify your use cases and work backwards. Don't jump into it, solving all the problems at once, which is good advice, sometimes very difficult to follow. I think people will look forward to your workshops and talks. I look forward listening to that. In the meantime, thank you very much for your time, and I wish you all the best.
Thank you,
Thank
Peter.
you, Peter.
Thank you, Peter.